This is Corey Willis with PPEI, and you're listening to the Diesel Podcast.
I'm Adam Blattenberg from Diesel World.
This is Dan, owner of Dan's Diesel Performance.
I'm Kaz from Diesel Doctor of Tennessee, and you're listening to the Diesel Podcast.
What is going on, Diesel Nation? We're excited to have you guys with us today on the #1 diesel truck podcast on iTunes. I want to thank you guys for all the support and the new follows that we've been getting on Instagram and Facebook and show suggestions. And this episode is a direct result of that. We had a bunch of people message into us and they wanted us to talk with Matt Santjer from Santjer Performance about his new billet input shaft. And it's something that's really cool. And the 5.9 guys out there, or if you got a 6.7 and you did a 48RE swap, you're going to be interested as well. And that's how they were able to come up with a new billet input shaft that's designed to hold a ton of power. And it's not just for race applications, you can also run it on a daily driver. And so we're going to go through the engineering behind it, what made him think to do this shaft, you know, his truck and things he went through with it. So we know you guys are going to love this episode. Before we get to it, though, we want to thank two of our sponsors that help make episodes like this possible. First is BD Diesel Performance. Make sure and head on over to dieselperformance.com. Check out a ton of different products they have, from injectors and electronics and hard parts and transmission pans, tons of different things. And you can search by year, make, and model. And also Diesel World Magazine. Make sure you go to dieselworldmag.com, bookmark that page. With race season coming up, a bunch of events are going to be happening, and they're covering it all. So if you want to know the latest about races, products, builds, reviews, tons of things, those guys got it. All right, let's get to the podcast with Matt and talking about this new billet input shaft. Matt, welcome to the Diesel Podcast. Today we're going to be talking about the final fix for the 48RE input shaft. I'm excited to chat with you today.
I appreciate you having me.
Well, we've primed Diesel Nation on social media, and we told them we were going to be chatting about this new billet input, which I think it addresses a lot of different issues. Like, you know, 5.9s are kind of like the holy grail of diesel performance, and especially I think over the last 3 or 4 years, all that can be done with engine technology and fueling and turbos and tuning and things like that. And we were talking before about, you know, input shafts, specifically I think in, you know, trucks that are making good power and trying to make that setup more reliable. And I wanted to ask you about what you designed, what you came up with, and have you tell our audience a bit about your input shaft.
Awesome. Yeah, so in our experience, we've found that the current aftermarket solutions for the 48RE and 47RE input shafts, they've been sufficient for some time early on, but like you mentioned, as trucks have continued to make more and more power, and you have more and more street trucks making well over 1,000 horsepower and pulling trailers and really seeing a lot of long-term abuse and fatigue, that some of the high-stress areas and relatively common failure points are just becoming more and more common failure locations. So we'd been fighting the same issues as everyone else. I've had 12 or 13 input shaft failures over the past 10 years, and I mean it adds up. It's definitely a very expensive problem to have when it does occur. You probably wipe out your stator support and pump, and might wipe out your converter and put trash to the trans. So there's a lot of damage that occurs when these things break.
We've chatted with a lot of, you know, racers over the years, and I remember back maybe 2 or 3 years ago, and it was like you could get a certain number of passes out of that shaft, and then you're going to be pulling the transmission in the pits, and depending if it's fixable there, getting it back, you know, getting the training put back in and trying to finish the race. But then it also extends, I think, to daily driving and even towing. You know, if the power level is at a certain point and you've got a full weight truck, maybe bigger tires on, and it's just like, and you're the expert on this, but it's like there's only so many shock loads that shaft's going to take. And it's kind of like you see those stories where someone's like, yeah, I got 1,200 horsepower and I haven't broke it yet. Well, how many times have you put the power through it? It doesn't necessarily break the first time. It could break the 20th time, the 30th time, the 18th time. You just don't know. And what was so cool about seeing what you have is it's different than anything that's been out there. And I wanted to really kind of get into the details of it. Is what makes this input shaft different? How much larger is it than, say a standard, billet input shaft? What kind of torque and power have you seen it hold up to?
Yeah, so as far as size goes, it's inch and 3/16 major diameter on the splines, but it's a very fine 37 spline configuration. So the minor diameter of the shaft is substantially larger in comparison to, say, a coarser spline, something similar to like the 23 spline that came in the trucks originally. So the minor diameter is what that's what dictates the torque carrying capacity of that shaft. If you were to look at a cross section, that's going to be your smallest cross sectional area, and that's what dictates how much torsional strength that shaft has. And so what we did was basically increase the size of the shaft as large as we possibly could, in combination with the size of the stator tube, so that we could still fit it through the factory pump gear and require minimal modifications on the transmission side. We really put a lot of emphasis into ease of assembly for a trans builder. That way they're not having to either modify or machine components themselves, and they don't have to replace the pump gear assembly. They can really just put the thing together just as they would with a factory input shaft configuration. Majority of the changes are on the converter side, and they won't have to deal with that. There's converters available from multiple converter manufacturers right now, and they can order the components through them and put the trans together just how they normally would. So very very minimal changes on their end. As far as specific design aspects of the shaft that really set it apart from the factory configuration is obviously it's completely solid. We've been able to eliminate the cross-drilled holes and sealing ring grooves, which is what we found to be by far the highest stress concentration of any location on that shaft. And in the analysis, the computer FEA that we had ran, it was very extensive. Originally I went down the path of trying to kind of like super optimize that section and figure out how to minimize stress and still retain those features. And what I kept coming back to was that section just needed to get so much larger in relation to the rest of the shaft that you really ran into issues in the stator support itself. If you were to kind of look at a cross section of the, say, like a factory stator support casting, if you were to increase that section where the sealing ring grooves and cross drill holes are, you would have very very little material in the stator support itself, and then you start kind of it's a snowball effect. If you have to change that section, then you have to change everything downstream. Everything has to start getting bigger and bigger, and then you have a whole bunch of additional components and added cost to the setup. So we really wanted to stay away from having to increase that section. And what we ended up coming back to was, why can't we get rid of it? It's not the first setup that's or first application that has a solid input shaft. So obviously it's been done and it can work. And in this application, it's proven to work really well. We've basically just had to change the fluid transfer flow path to and from the converter. And by doing so, we've also been able to address another major issue that's slowly developed, I think, and gotten worse over the years, which is the fluid restrictions through the input shaft. That seems like as the aftermarket industry has evolved and tried to make improvements to the input shafts, they've like decreased the size of the fluid ports, the cross-drilled holes, the kind of decreased the center fluid passage through the shaft, and those restrictions have caused new issues, because as your lockup piston and the converter applies, you have to dissipate and discharge all the fluid behind it quickly in order for the piston to apply. You have that small amount of motion that occurs to allow the frictions to interface, and that fluid volume behind there changes. So in order for a quick lockup to apply and to minimize slippage, you've got to be able to get that fluid out quickly. So by adding restrictions in line, it causes the converter clutch to momentarily slip as it's being applied, and every time it does that, you get a little bit of glazing, a little bit more glazing, and that's what causes converter clutch failure, especially in the lower, well, I guess really across the whole spectrum as far as power levels. But you really shouldn't, say a triple disc converter, you definitely shouldn't have your 5 and 6 and 800 horsepower guys burning up converter clutches. They're not doing it because they're making too much power or they can't handle the torque. It's definitely due to other reasons, and this is definitely a major contributor. I mean, there's 3 frictions has plenty of torque carrying capacity, way in excess of what these trucks are making. I mean, there's definitely a underlying issue. So we've been able to address that as an additional improvement to overall strength increase of the shaft and reduce stress concentrations and whatnot. So it's been working really well. We've had a number of trucks over the past year and had no failures. I mean, which is awesome. I mean, every time you have a new product available, you always wonder who's going to find the first issue that you got to address, and how quickly can you make an improvement and iterate, and haven't made any changes so far. So that's been really, really exciting.
That's what I was going to ask you, is what kind of power and torque is the shaft designed to handle?
So we've done a lot of our testing on a hydraulic torsion testing rig for our fatigue testing, and we've ran it at over 4,000 foot-pounds. And to my knowledge, I don't believe nobody that I know of is making 4,000 foot-pounds. There's definitely some guys making some huge torque numbers in the 3,000 plus range, but I don't think I've seen anybody crack the 4,000 foot-pound mark. And if they did, they're everything else in the engine and trans is at its limit and far past it. So I don't think that the input shaft is going to be a common failure anymore. It's definitely far superior to what was available before.
I got to ask you, is how'd you come up with this idea? There's always something that kind of necessitates an improvement. What inspired you or kind of pushed you in this direction to totally rethink and redo, I think, what's been a major problem on these trucks in racing, or just making, big power with them?
It's really been a progressive issue over the years. I mean, and I had gone through quite a few stages where I was like, all right, you know what, I'm just going to detune the truck a bit. I'm tired of breaking stuff, and I'll just try to cut it back a little bit and try to get shafts to last for a couple of years maybe, and then I would progressively change my mind and start racing the truck more and beating on it, and then I just continuously had failures, broken all the oversized shafts and multiples of them, and obviously all the standard shafts early on. So I think that the last failure I had was at an event. I'd just gotten there, was getting the truck prepped, went out and made one start to a pass and immediately broke the input shaft. It had to have barely been hanging on. It had major cracking originally, because I was probably making 30 pounds of boost when it broke. It barely saw any load and broke. So it was obviously barely hanging on. And at that point, I just kind of was like, that's enough. I had enough ideas to make improvements, and that's when I parked the truck. It was over a year that it sat, and I was not going to put it back together until I had something new in it that I developed, or I stuck to it. It sat parked for over a year before I had it up and going. So, and it's kind of a good thing because it kept me motivated to keep pushing and find a good solution. And yes, that's the story behind it. It's just kind of been a progressing issue that I always kind of knew there was better things available, but they never came to market, and so I tried to figure things out.
What kind of power level is your truck at?
It's in the 1,500 horsepower range. It's a full weight 7,000 pound street truck. I mean, I daily drive it and do quite a bit of racing with it. I've gone 638 at 111 mile an hour with some 140 60 foots. I mean, it's a pretty stout street truck, and I've been putting a hurting on it since I put the shaft in. I've broken plenty of other stuff since then. I've torn my transfer case to pieces. It demolished the case and snapped the front drive shaft. That was going down the track at over 100 mile an hour when that thing let loose. And I've stretched main cap fasteners in the motor and had to pull it out and get it put back together. But no input shaft failures, so I've been happy and haven't had or any other transmission failures as well, because that's one other thing that is a pretty substantial design improvement, is the overall length of the shaft has been increased dramatically. It's almost an inch and a half longer in overall length, but the increased length that the shaft has to deflect over is almost 4 inches really, because the section where you had your cross drilled holes and sealing ring grooves, since we've eliminated that section, was able to decrease the diameter of it. So it's a very, very minimal section change from the primary diameter of the shaft. So you've added that whole length to the length of shaft that can deflect. So by having that long length, you've effectively got like a torsional damper in line, and I think it plays a big role in dampening shock loads for components downstream from the input shaft. I think that's definitely a important thing to mention, because I have heard a few comments from guys saying, "Oh well, I'm putting in a much larger input shaft. It's super rigid, and you're just going to find the next failure point type deal." And that's really not the case. I mean, yes, it is larger in the areas that really count, like your transition from your minor diameter to the major diameter, or from your minor diameter of the spline to the primary shaft diameter. It's actually slightly under the minor diameter. So you have I guess the primary length of shaft isn't massively increased in relation to say other aftermarket oversized shafts. It is larger, but it's not. It's definitely not making a. It's not causing issues. It's really improving the dampening ability of downstream components. So
I've heard that talked about before. I think just over the years with input shafts is they have to have a certain amount of give or flex. But if it's too rigid, well, then it's just going to snap. And so I know there's science that is going to be above my ability to comprehend that goes into this, but for the listeners out there, is like that's been accommodated and figured into this design, which is I think why everyone's so excited about it. Is it has the ability to hold these power levels in an extreme sense, but you don't need to have a 3,500 foot-pound of torque truck to run it. Like there are people who have issues with billet inputs below 1,000. We're right at 1,000, and you had touched on it earlier with how expensive it gets, and it is. You snap an input shaft, maybe you just snap it, and it damages the converter. Well, the truck's not moving. You can't really drive it, so you're gonna have to get towed somewhere, and then you gotta take it to a transmission shop, and then they're gonna pull it. And there's labor money there, and then it's like, oh well, we need a new pump, a new input shaft. There's metal that went through the transmission. We got to clean the whole thing out, rebuild it, put it back together, get it in the truck. And it's like you have that happen a couple times, you've already spent more than what this shaft costs.
I mean, you have it happen one time from a standard input shaft that to this. I mean, you're definitely in the hole. By breaking one standard size input shaft, you're putting more into that trans than if you were to start with this setup. Definitely, there's a lot of hidden costs. It's not just, well, I'll put another $600 shaft in it and keep on going. There's definitely some hidden costs that the guys need to think about. So unless they're absolutely confident that they only need a slight improvement over factory, it's definitely something they should at least look into. And there's no downsides that kind of make it a race only application. It's not like it's hurting converter flow and your trans is going to get hot if you're driving it on the street in slow traffic or anything like that. That's complete opposite. Everything it's all beneficial improvements for street and racing application. That was definitely another major design constraint that we wanted to keep in mind, was that it wasn't just going to end up being a race only application, because there's tons of products available like that yes, they improve something, but you're giving up something else in turn. That's probably more common than not.
That's one of the things too, like in a general sense, where I'm really passionate about it because I'm an enthusiast first, and I've been following trucks and owning trucks, and just being around the community for so long is, we think of, hey, I got this truck, I want to have some fun with it. And we don't mind spending the money on the nice looking turbos or, the injectors, all these other things, right? But when it comes to the transmission, it's like, well, I'm never going to see it. It's underneath the truck. How am I really going to talk about it? Is it really that cool? Not really. But it's such a hidden cost, and I've seen it with friends, with people I know, is you can spend thousands of dollars on just by breaking a shaft. You can have the best billet parts in the transmission. There's great converter companies out there, great converters and different things you can do with the transmission. But that input shaft on the 4748 RE is the weak point, and that's why it's so exciting to chat with you. And what you've done with this transmission and this upgrade is, I guess people can break billet intermediates, billet outputs, different things like that, but it's not as common as the input. And I've talked with people where some of them have broken 7, 8, 9, 10 of them, and they might have the resources to pull it and fix it themselves or something. That's still time, that's still money, and that's what's really cool too. Like you mentioned, is this isn't just for, a 2,000 horsepower truck or 2,500 horsepower truck. Is anyone can use it, and it's worth considering it on a build. The transmission is going to be expensive, to upgrade. There's a lot of money that goes into it. You don't want to have to go through it again.
Yep. It's definitely it's a substantial investment putting together any moderately built transmission. I mean, even if you're not going all out, they're still expensive. There's a lot of money tied up in a properly built transmission. So I mean it's component costs and labor. So, and you're gonna pay for both of them when a shaft breaks. So and honestly, it seems like over the past few years, with guys with the current aftermarket shafts, I think as guys have tried to make some improvements on them. I don't know if they're adjusting their heat treat processes or whatnot, but I think to me it seems like maybe they're starting to try to heat treat them to a higher strength level, and almost having a negative effect, and causing more damage when they break. Because it's a fine line as far as heat treat goes. You have your ultimate tensile strength of the material, which it is what it is. It's not going to change as a constant material property. And then you have your yield strength, and depending on your heat treat, that's what determines the yield strength that you achieve, and it's guaranteed to be below your ultimate tensile strength, but it's completely dictated by your heat treat. And so the higher yield strength level you heat treat to, and that's going to be dependent on how you temper down from your like as quenched condition, is going to determine how brittle it is. So it's a very fine line. I mean, you want to achieve the maximum yield strength that you can without making it too brittle to where it fails prematurely due to a different failure mode, like brittle fracture or something else. Because you're either going to have a brittle fracture or you're going to have a ductile failure. And what it seems like guys are trying to do is to get that little bit stronger yield strength, they're heat treating them they're pushing the limits and trying to get really close to your ultimate tensile strength. And you're definitely in the extremely brittle range. And as they're failing, they're wiping out other components almost guaranteed, and kind of breaking in like in a spiral fracture, and just kind of almost exploding outwards and shattering stator tubes and impeller hubs and everything else, where before, if they were a little bit more on the ductile side, they'd break off a little more cleanly. Maybe it wouldn't wipe out your stator support and stuff. You would just have maybe the end of the shaft would broke off in the converter, but if you can get it out, maybe you can salvage your converter. But it seems like that's happening less and less these days, as the different current aftermarket manufacturers are trying to push the limits and get that last little bit of strength that they can. So it seems like in the past couple of years, maybe it's just because I'm kind of following it more closely, that some of the failures have been pretty horrific. They definitely have caused some major damage. That it's definitely not just going to be the cost of a shaft itself.
Well, and if you really want to see an upset diesel truck owner, is have them spend $5 to $10 on a transmission and go out on the first couple wide open throttle runs and snap a shaft. And it's bad.
Put trash all through the trans and all your brand new components that were nice and fresh and brand new that probably aren't going to get replaced. I think it happens more often than guys want to maybe care to think about when they're trying to decide, should I spend a little more money and kind of more or less have an insurance policy, or hope that it hangs in there. I mean, definitely, I think it's a decision that a lot of guys probably have a tough time making the call on, but it definitely seems like there was a need for a better solution. And we'll definitely continue to get more feedback and data from the racers over the next couple race seasons, and if there's anything that we can do to iterate and improve on the design, we definitely will. As of right now, I've been really happy with it. I don't think that the next manufacturing run of them is going to have any changes, and we're going to stick with what we've been able to prove so far, and it'll something else would have to come up for us to want to make any changes, but we're always open to suggestions and improvements, and definitely lots of intelligent transmission builders out there. I mean, since we've released the product, I've been able to talk to tons of guys that never would have otherwise, different shop owners and trans builders, and it's been really interesting to talk to all these guys and pick their brains and listen to all the different experiences they've had over the years, and it's definitely been an exciting process.
When it comes to the converter, I think that's another part where there's a lot of brand loyalty, almost as much as Ford, Ram, or GM. When somebody orders your input shaft, what do they get, and what converters will it work with?
So when they order the shaft, depending on where say they order it directly from us, they get the shaft with the hub installed, and they would get the stator support assembly, and they would purchase a compatible torque converter from one of the primary manufacturers. You have DPC, Suncoast, DD, GoRend, and they've all built converters for them. They've all been working really well. They're familiar with the components available. We're providing the compatible converter components for them to build with, and it's nothing that it's not a huge cost increase to the converter themselves. I believe on average it's been maybe an extra $150 or $200 per converter, and they can go to either their current converter manufacturer if they're going to be sending in their converter to get rebuilt, or they can order a new one. It's really up to them. I mean, Phil at DPC, he got involved early on. He was awesome to work with. He sent me converters and whatever I needed to test with. I mean, he's built a ton of them, and now, like you said, there's lots of brand loyalty as far as converters go. So there was lots of guys that were diehard Suncoast or diehard BD or GoRend, and once they've started running something and had good luck with it, they don't want to change. So kind of definitely forced us to have to make available other brand converters for guys. And everyone has been really open to work with, and they've all been able to easily adapt to the changes and integrate into the converters. So it's been actually a really seamless process. I never would have anticipated it going so smoothly, actually. Early on, whenever I was first kind of starting things before really working with any of them, that was always something that was in my head. I was like, well, am I going to need my own converter to work with it? I actually, at the same time, I had started developing a bolt together converter right when I started the input shaft development, and that was the original plan. Honestly, it was to have my converter and input shaft, and that was the route I was going. And to get things going quicker, I had ran DPC converters in my truck prior. I called up Phil, and he was really interested and super helpful. And so to get things going quicker, he built me a converter with my parts and got out, and I started running it, and I was like, man, this works. It's working really well. So I kind of just put my bolt together converter on hold for a little while, and it was just afterwards that it seemed like the diesel industry started catching on, and then multiple bolt together converters were becoming available from different guys like DD and GoRen and whatnot. So I just kind of set that off on the side burner and focused on the shaft, and it kind of process just kind of went on, and decided to just let the current converter manufacturers do their thing, and they can help out with distribution. And because at some point, I don't have a huge sales staff, and it would be, I guess, ideal for me to manufacture and provide the components to these guys, and they can help out with the distribution, and everyone can be happy. So,
and for any of our listeners out there, like, you know what, I've been having input shaft issues. I'm ready to try this. Or there's a shop out there, or even a converter company. It's like, hey, I wanna be able to offer a converter for this. What's the best way to get in contact with you guys? Is it social media? Is it calling in, sending you guys an email? How do people find you?
Yeah, that's honestly, social media has been definitely the primary means of communication. I hadn't put out a contact phone number for everyone to contact me at, to try to, so I can keep focusing on development and manufacturing and whatnot. But honestly, it seems like, Facebook messaging, that's in 99% of the communication. Honestly, I think even if I had a phone number and everything available for guys, I'd still probably get more Facebook messages than anything else. It wouldn't have really thought that, but definitely became much more active on social media than I ever had been before, answering messages and trying to do my best to keep up with different comments and things that the guys have online, and questions and whatnot. I'm sure there's plenty of discussions and things that I miss or I get too late, but I try my best to answer questions that everybody has. So only so many hours in the day.
What's your Facebook and Instagram name?
Instagram is Santjer_Performance, and then Santjer Performance Development LLC. On Facebook is the business page, and then also my personal Facebook is Matt Santjer. And Santjer is spelled Santjer. Probably not the easiest last name to spell, but it's there's not a whole lot of other Santjers out there that I know of.
Well, I know.
If you can't figure out how to spell it, it's probably easy to find if you can search it. So.
I know you got a lot of loyal fans out there. We had a lot of people reach out to us, and they're guys with big power trucks. So, like, you got to talk to Matt. You got to talk to him about this input shaft, and it was cool to be able to connect with you and talk about it and see all the engineering that went into it, and the thought and the testing, and then how many people are running it, and who's going to be running it at UCC and DPC and through ODSS and just tons of different things. And we've had a lot of guests on that are running your input shaft, which I didn't know, but when we posted up on Instagram and Facebook, these former guests are like, hey, I'm running that, it's awesome, I'm going to be testing it here and doing this. So it's really cool, and I would encourage people who are listening that if they've been through these issues, or they just want to have the best transmission setup they can for their 5.9, or if they've done a 6.7 swap or a 48 swap on their 6.7, it's definitely worth looking into for a lot of reasons, but especially because of what it can cost to break input shafts. And it's one of those hidden things like we talked about earlier where people may not think about it, but you have it happen once or a few times and you're several $1,000s into it. And it's cool to see a solution where it doesn't need to happen. Now, you can get the transmission, put it in the truck, go race, and you're going to find other things, whether it's, like you talked about with the engine or turbos or just different things. We'll focus on that instead of, the transmission shearing an input shaft, when you launch, or you go race and have fun and then you go to drive work the next day and you go down the street and pop, there it goes.
Yeah. I mean, there's always going to be other components that are at their limit. I mean, at some of these power levels, damn near everything's at its limit. And if we can address one of the primary issues, it'll give us more time to work on some of the others. I mean, there's always going to be other ones. I mean, but I do think it's important to note that it's definitely not going to kind of just shift the issues downstream or make any of them more worse. So, I mean, I think I've heard a fair amount of guys kind of mention, I don't know, almost kind of treat the input shaft as like a fuse, kind of like it's going to prevent them from breaking more expensive things downstream type mentality. And I really think that's not a good approach to look at it, because as we've talked about, that's a pretty expensive fuse. I mean, maybe you could look at like an output shaft like that. Maybe say a standard size output shaft. If you really want to fuse, I mean, at least that doesn't cause as much damage when it breaks.
True.
But the input shaft is probably not a place that you want to have a sacrificial component, even if you're trying to, I don't know, protect things downstream from it. I think I've heard it a handful of times, and I always kind of cringe when guys start going down that path. But everyone's is obviously open to their own opinions, and we'll definitely have to. Interesting to see how things progress, and definitely look forward to getting more feedback and data from guys as more and more guys run them. We have a handful of trucks out at UCC running them, so that's going to be real exciting to see. I've got my plane ticket booked. I'm going to fly out there, and obviously I'm not competing, not with a street truck, but it's going to be definitely a good time out there, checking out all the action and seeing what kind of power these guys put down on the dyno, and that's going to be a pretty substantial test as far as the shafts go. I mean, a lot of times they're not making they're definitely not making those torque numbers going down the track. If they did, they wouldn't be hooking up. They would have other issues. So when they load them down a real low RPM on the dyno, and they're trying to get as big a torque numbers as they possibly can, that's definitely hard on everything in line and the powertrain. I mean, the big torque numbers like that is definitely the killer. I mean, guys can get by when they're turning $5,000 or $6,000, but when they're turning low RPM and making big torque numbers, that's the killer for sure. So it'll be cool to see some of these guys give it their all and see what kind of torque numbers they can put down this year.
Well, we really appreciate you taking time out of your busy day to chat with us today, answer these questions, and a lot of those guys that message into us are like, hey, you got to talk to Matt, get him on there, ask him about the input shaft. They'll be able to hear some of the details that people are going to want to know, and yeah, it'd be cool to chat with you, maybe after race season and see what you think, see what kind of feedback you got, and just hear more about it. So was cool to chat with you and learn more about this setup.
Yeah, I mean, I really appreciate you having me on the show and talking to you, and definitely look forward to talking to you in the future. Give you some updates, and hopefully we have some new things to talk about, and I think maybe some new products in the future. So there's always going to be new issues to address. So keep on plugging along and see what we can come up with.
Don't forget, Diesel fans, make sure and head on over to dieselperformance.com. Check out what BD Diesel has for your truck, and also dieselworldmag.com. Bookmark that page or pick up an issue, and you can stay up to date on the latest in racing, products, builds, and tons of different things. Till next time, keep the shiny side up.